All right, before we get into the rational zero theorem, I want to think about polynomials in general. First of all, when it comes to y equals x cubed plus 4x squared minus 2x plus 1, this is a third degree polynomial, and its leading coefficient is positive 1. Because it's positive, it's going to go up on the end. Because its degree is 3, it's going to have 2 terms at most. All right, so it's going to look something like this. For y equals negative 3x squared plus 11x minus plus 4, that's going to be a parabola that opens down. And when y equals 1/3 x to the 5th plus 7x to the 4th minus 6, 1/3 is positive. And since it's a 5th degree polynomial, it's going to have 1, 2, 3, 4 terms. So something like this. Now my more important question is, how many zeros could this thing have? And at most, we can see how many zeros it would have by looking at how many x-intercepts it could have. And that'd be if the x-axis ran right through the middle of the polynomial. Then in the first one, we see that we'd have 1, 2, 3 zeros, or 3 x-intercepts. Here, with the parabola, we could have at most 2 zeros. And for the 5th degree polynomial, we could have 1, 2, 3, 4, 5 zeros. What's important about that is that there's this theorem that says that when it comes to any polynomial, the number of zeros that it has is equal to the degree of the polynomial. So since a parabola is a 2nd degree polynomial, you have 2 zeros. 5th degree, 5 zeros. So let's think about a 2nd degree polynomial. F of x equals x squared plus bx plus 6. If we were going to find its zeros, we would factor it, right, if we could. If we're looking for just rational zeros, then we could definitely factor it. When we factor it, we would factor the x squared first into x and x. And since we have a plus 6, these would both be plus. They could both be minus, but they would be the same. And then we would fill in some number here. And we have a limited number of numbers that we could plug into those constant spots. We're either going to plug in 1 or 6, 1 and 6, or we're going to plug in 2 and 3. Okay? And because of the plus or minus, any of these could be positive or negative. And so we think if we were to have x plus 2 and x plus 3, then what would my zeros be? And they would be negative 2 and negative 3. Conversely, if I put in x minus 2 and x minus 3, those zeros be plus 2 and plus 3. In fact, we can quickly see that all of my possible rational zeros go back to those same numbers that I just could have plugged in, either plus or minus 1, 2, 3, or 6. They had to be factors of this 6. And if there is a leading coefficient there, that 3x squared, and we wanted to factor that, we would break it into 3x and x first. And then we would have plus or minus in the middle. And again, these factors, possibly plus or minus 1 and 6, or 2 and 3. Now, when we try to identify what our possible rational zeros are going to be, again, they are going to be plus or minus 1, 2, 3, or 6. But that's only going to come if they were plugged into this spot. What happens if they were plugged into this other spot? Then, if we were to have a 1 here, the rational zero that would come out of it would be either plus or minus 1/3. And if we plugged in 2 into that spot, now the zero that comes out of it is plus or minus 2/3. So it could also be 3/3 or 6/3. But of course, 3/3 is already on the list as 1. And so is 6/3 already on the list as 2. And so we can see that our possibilities for our rational zeros are going to be these kind of fractions where we have a over b, all right? Where a is going to be a factor of 6 and B is a factor of 3. And that's kind of the big idea that we want to identify first, is to be able to identify what our possibilities are going to be.